let's take a look at some more interesting exponential equations. Here's what I want us to take a look at. It's really going to illustrate a whole new line of thinking. E to the power 2x minus 6e to the x equals negative 5. Now, this seems really tricky. And notice that the x's appear twice. There's no clever way of just combining them because this is e to the 2x and this is e to the x. You just can't kind of subtract them. But the trick is to realize a fact about exponents, which is that e to the power 2x is really equal to e to the x all squared. Because remember, if you have e to the x and then square it all, you multiply the exponents, and that's e to the 2x. Now that's the breakthrough here, because then we realize this is really a quadratic in disguise, and this is a quadratic type, sometimes people would call this, of equation. So armed with that, because I see a 2 in the exponent, I'm going to bring everything over to one side, because again, I want things to equal 0. So we'll see this unfold live. So here we go. First of all, I'm going to get everything over to one side, and then I'll try to outline what I hinted at just a minute ago. So I'm going to add 5 to both sides. And I see this. Now here comes the tricky part. This is the part that's really interesting. I'm going to rewrite this as e to the x, but all squared. See, there's the quadratic part. And then I'm just going to copy everything else out. You see, because here the rule is you multiply the exponents, and that's 2x. Now this is awesome because you see now it really is just a quadratic. It's something squared minus 6 times the something plus 5. In fact, if you don't like that, you could even just change that and just call that E, like a capital letter E. Let me just do that for fun. I'm going to do it just for fun, just for you. I'm doing this live. You might say, really, you're doing it live? Well, you can see I'm doing it live. I'm cutting it. So if you don't like that, just call that thing inside there a big capital E to stand for exponential. And then at the end, remember that E actually equals little e to the x. Now, what happens if we try this? Well, now it's just a good old-fashioned quadratic that we've thought about tons and tons of times. Let's see if we can factor it. Let's hope so. Oh boy, I hope so. I hope so. Well, I'm going to have an E and an E. This tells me the signs are going to be the same, and this tells me they're going to both be negative. Two numbers that multiply to give positive 5, but add to give negative 6. That's easy. It's just 5 and 1, right? Negative 5e, negative 1e is negative 6e, and negative 5 times negative 1 is 5. Great. So therefore, I immediately see that I get two solutions. Either this equals 0, which means e equals 5, or this equals 0, which means e equals 1. Well, you might say, oh, great, we're done. The answer is 5 and 1. No, because that's e, and the original question was in terms of x. So you have to remember now what the e was. That capital E was a placeholder for none other than e to the x. So now I'm going to plug that back in here, and I'm going to see that the e is really e to the x, and that equals 5. And this is saying e to the x equals 1. So now I've got to solve these little exponential equations. And the best way to solve an exponential is take the log of both sides, because a log kind of kills an exponent. And when I take the log of e to the x, I just get x. Either by thinking about it, log is base e, so e to what power equals e to the x? It's the x power. Or bring the x out in front, and that's x log, natural log of e, which is 1, so just x. Either way, what we see is x equals natural log of 5. And if we solve this one, actually, you can almost do that in your head, right? E to what power equals 1? The answer is actually something I know. It's 0. But you could take the natural log of both sides if you want. But you know what? I'm not even going to do that. I'm going to show off a little bit here and show you that I can say that x has to equal 0. So there's one solution. And here's the other solution. If you don't like the natural log of 5 as a solution, which is the exact value, you can approximate it. Look at it on a calculator, and you see it's 1.609. If you want to round that to the nearest 100th, it'd be 1.61. But you get these two different answers, two different solutions. Not surprising that we get two solutions, because in fact, really, this was a quadratic in the skies. It was a quadratic of exponential type. Really, really cool. The cool thing is that when you see an e to the 2x, and then somewhere else you're adding on another e to the x, think to yourself, that e to the 2x is really e to the x all squared. And once you start thinking that way, you're going to see the quadratic type of the equality pour out. Factor away, solve carefully, replace in the e to the x, take a couple logarithms, you're good to go. I'll see you soon.